Hello and welcome to another exciting edition of Introduction to Operating Systems and Virtualization. My name is Scott Neal, and for the last several episodes we have looked at different types of operating systems, particularly from a virtualization perspective. We have introduced you to the world of virtualization, particularly in VMware. Certainly not the only vendor-specific virtualization platform we'll cover in this series, but what we've been highlighting in recent episodes. And the last episode, I believe we were looking at doing physical to virtual environments, being able to take a physical box and virtualizing it, talking about how that helps consolidate or contain our data center and our physical world of servers. So today I want to change it up a little bit and look at Linux operating systems. We're going to be talking about, particularly in this episode, as well as some how-to segments, we're going to be looking at the history and the importance of Unix and Linux as an operating system. We're going to look at the characteristics of Linux as well as understanding the steps needed to install Linux on a virtual machine. We'll do a how-to segment on that. We're also going to do a how-to segment on virtual tools and a VM for Linux. There are some special considerations there. We're going to look at some virtual machine configuration options for Linux as well as some optimizations for Linux as a virtual machine. So I really would like to go ahead and get started with history. So in the 1960s, if you remember, back in our very first episode, we were looking and talking about operating systems and the evolution of operating systems. And one of the things we pointed out is that operating systems in the 60s really kind of focused on batch operations. They used punch cards and perforated strips as a means of taking data and entering that data into the operating system. It then regurgitated an answer provided that nothing went wrong. However, lots of times things did go wrong and the error messages pretty much meant nothing to the user. It meant they had to go back and totally re-examine how the data was entered. Well, what could have gone wrong with the operating system? Debugging overall, therefore, was very inefficient. So a group of fellows decided it was time to evolutionize operating systems and make them more user-friendly and simpler to use. And Multiuser was one of the very first evolutions of the operating system. It did allow you to work in a dialogue with the computer. So even though it was strongly influenced by the batch operation and difficult to operate, it really was an evolution or the beginning of the evolutionary process for operating systems. Ken Thompson, who was a Multiuser developer in 1969, said we can take this a step further, and he began developing an operating system that really was designed to provide a higher level of functionality, but at the same time remain somewhat structurally simple to use. So in 1969, 1970, he really worked on this UNIX operating system. It was written in assembler, but then it was rewritten in 1971 to C. C has some benefits that we'll talk about in a little bit. The system spread quickly, and the reason why the system spread quickly is that Bell Laboratories provided the documentation and the source code to Unix to universities across the country at almost no cost. It was a lot simpler to operate than Multiuser and previous versions of operating systems, and because the source code was available, that meant that people could take the Unix operating system and tweak it to their personal computer environments. And that was a very powerful thing to do, to be able to release this source code, let people have access to it and modify it. In turn, they would send their altered operating system code back, and people could then use that or modify it further. So a lot of people got involved, a lot of companies started getting involved and started getting actively engaged in the development of the operating system itself. This led to a very high level of maturity very quickly. Now when we talk about a high level of maturity in an operating system, we're really looking at the level of functionality and features of that operating system and how quickly they gain additional features and functionality. And because this was a virtually open source code, that was one of the leading benefactors towards raising the level of maturity of the operating system. A series of commercial Unix derivatives, no doubt, were developed very quickly. BSD Unix, Berkeley Software Distribution, came out in 1978. And in 1983, AT&T began marketing the Unix System 5 operating system. AT&T, a very large organization, even back in 1983, decided that they were going to try to proclaim System 5 as the Unix standard. And they changed the licensing considerations significantly. So that led to a lot of Unix vendors being disgruntled and upset with what AT&T was trying to do, which was capture the Unix market. So quarrels began between the vendors, and that prevented a standardization of the Unix family. So even today, when we look at Unix environments, and yes, there are Unix environments out there, one of the questions that we can ask is this a BSD derivative or a System 5 derivative? And most Unix operating systems can be traced back either to System 5 or BSD. One of the nice things about Linux is it tries to incorporate the best of both worlds. Linus Torvalds, who was a Finnish student back in 1991, developed the rudimentary kernel for Linux, and then he decided to pass on that source code to others who were interested using the internet. And a lot of people took interest in Linux. They have been Unix users for a long time. They saw the potential benefits of having Linux out there as a source that with source code that was made freely available through the general public license. So Linux then began to become rapidly developed into a project involving lots of people. The development of the system's core, or the Linux kernel itself, is still coordinated by Linus Torvalds. So things like the input-output controls, the process management, device control, file management, all of these things still fall under Linus Torvalds' purview. He still makes the final decision as to which new features are actually introduced into the kernel and released. This is Linus Torvalds here. He is the creator of Linux. He's got a pretty good gig, actually, when you think about the fact that he spent probably the last 30 years or so doing a lot of flying around, promoting the product, talking about the product, consulting about the product, and so on. I think that Linux has worked out well for him. All right, so let's continue on with the development of Linux. The other system components, not including the kernel, but all the other system components and modules are maintained by other groups or other people. So even though the kernel is maintained by Linus Torvalds and his entourage, if you have you install different modules, different packages, most of these packages are going to be supported, updated, and troubleshot by different groups of people who really developed that from the onset. That does lead to some inconsistencies when it comes to supports and updates. Some packages, modules that may be out there may no longer be supported. Others may be very heavily supported and very heavily used. So it really just depends on what you're installing in Linux and the purpose it's serving and who is backing up that product. There are two current versions of Linux that are in development. There's always a stable version. Stable versions are always identified by an even number after the first dot of the suffix, while developer versions are usually identified by an odd number after the suffix. So Linux distributions are based on the even numbered versions, and they often provide current development kernels, which under certain circumstances may be needed for the integration of new hardware components. Now, one of the big benefits about writing an operating system in Linux is that it is capable of being run on a large variety of platforms. This would include for Linux something as old as an i386 32-bit system. I can run Linux on it. It doesn't really matter if I'm running it on an Intel chip or an AMD chip, or whether it's a 64-bit chip. It will run on PowerPC, Spark, IBM, whether it's P-Series, Z-Series. It even runs embedded. So if you have a lot of old boxes and you are not willing to get rid of those boxes, but you want to utilize those boxes for something, then Linux may be an alternative to using one of the newer Windows Server operating systems out there. So as you people who are trying to move to Server 2016, they are running into hardware compatibility issues. Server 2016 requires second layer address translation and so on. And a lot of hardware out there just doesn't support SLAT and a lot of the other things that Server 2016 needs. So what are your options? Well, if you're running an old piece of equipment and you need to improvise, use Linux. Linux will probably run on that piece of equipment. One of the benefits of Unix that we've known for years and years is that it is multi-user multitasking. Unix was developed with multi-user capability. That means that more than one user can access the operating system and utilize the operating system at once. Multitasking means that it has the ability particularly in a multi-processor system, of being able to run different types of tasks simultaneously. It does do this as preemptive multitasking. For those of you who don't remember what preemptive multitasking is, that just means that the operating system still holds on to control, so no application takes over the processor and holds the processor. That helps eliminate a lot of deadlocking and a lot of system hangs and so on. Even with multi-user multitasking operating systems, it's important to realize that managing all those resources and granting access to processes is still a complex task. Still, deadlock can occur. And so we have another trick up our sleeves called multi-threading. It's really an extension of multitasking. It does help further alleviate the problem of deadlock. And with multi-threading, we actually take a process and break that process down into smaller chunks that we refer to as threads. A thread really is some of the smallest independent processes that we can do for calculations that the processor can handle. And so we can take a process and divide it into independent calculations and then send those out to multiple processors at once. This does mean that we have the ability to increase the level of parallel processes with each thread. It's going to need to be administered, which makes the use of the multi-processor system much more valuable. Benefits of having a multi-user multitasking system, of course, means that we only have to install a program once in the operating system, and then that program can be accessed concurrently by different users doing independent tasks with that application. When you think about that, that's a phenomenal achievement. And when you think about the fact that Linux and even Unix being capable of doing this in the early 70s, whereas Windows and Mac were relatively newcomers to the multi-user multitasking environment when you look at the overall evolutionary process of operating systems. It really is a monumental achievement indeed that Unix was able to do this. If a number of users, of course, are active, then both programs and processes are able to be used independently. Fantastic thing to be able to do. As I said before, Linux, Unix, they're not the only operating systems that do this now, but Unix was certainly the first. All right, so why Linux? Well, Linux is a growing choice as a server operating system. We are seeing more and more people move to the Linux operating system environment. There are several reasons for this. For one reason is that as older proprietary systems start falling out of favor, then those legacy applications have to be migrated somewhere, and Linux seems to do a pretty good job of that. A lot of newer applications are really set up for open source architecture frameworks rather than vendor-specific solutions. So we're seeing a lot of people really look at the open source environment over vendor-specific solutions for their IT infrastructure. Linux is cheap to run in comparison to Windows. You have to pay for the licensing for Windows, which is not cheap by any stretch of the imagination compared to Linux. So the fact that we can run Linux, we can run it on hardware that's certainly much older than hardware that we would need to run newer Windows operating system environments, really lends itself to the fact that it's just a cheaper operating system to run. Installing Linux into a VM really is going to be quite simple. It's the same process as installing Linux onto a physical server. Now, with that said, it's probably a little more convoluted of a process than a typical Windows installation is. We still have to choose the boot device at power on that we're going to install the operating system for, whether that's a DVD or an ISO image. There are, for instance, some more partition options that we have to consider before we start building our build, particularly in the virtual environment. So when we do our walkthrough for the Linux install, pay particular attention to some of the choices that we make, as well as some of the choices that are available as we walk through the installation process. All right, so the Linux installer, bear in mind, can only see what has been allocated to the virtual machine. This is no different than the Windows installer when we're looking at building a Windows VM as well. So in this screen, we have built a 20 gigabyte hard drive. It sees, roughly 20 gigabytes in. So we are going to have to think about, when we start building Linux, there are some partition options out there that are going to be different in how we set those up than what we would do in Windows. VMware tools are going to be, or typically are installed to enhance the user experience. We've talked about VMware tools before. They do improve performance. They help manage the VM. They do provide that host VM interoperability. However, VMware tools has to be installed differently in Linux. There is a process for installing the VMware tools. You do have to install it on the system as a root user. The installation on a Linux platform is going to require file extraction and running it as a configuration script. And so when we talk about chapter 12 of the book, we're going to be talking about VMware tools in more detail. We're going to do a how-to segment in running VMware tools. Okay, so I do want to talk a little bit about optimizing Linux as a VM. There are certain processes really in Linux world are called daemons that run on Linux that are not going to be necessary in a virtual environment. So disabling some of those processes can save CPU and memory resources. Linux applications and functionality suites are distributed out as packages, installing only the packages necessary for the operation of whatever environment you're creating is going to save disk space and reduce the amount of daemons running on the box. So gathering metrics is going to be key for maintaining good performance. There are some processes to consider when we start talking about Linux environments that may be advantageous to disable once we've set up and installed Linux. If you're using SMBD and NMBD, these are really daemons for the Samba processes, and you have to ask yourself the question, do you really need to export SMB shares or Windows or another machine? If not, you can disable them from starting automatically when the machine boots. Telnet is another option that we can consider disabling, as well as the RO login. That's going to allow you to log into another host over the network. If I'm not logging into other machines on my network, I'll disable that. The rexec is another process I can get rid of. It lets you execute shell commands on a remote system. If I'm not doing that, if I'm not going to require to execute shell commands, then I might as well disable that process as well. FTP and auto mount are two other good ones to disable. If I don't need to mount different file systems automatically to bring up the network file system, I can disable it. Named runs the name server, the DNS. So I can disable that to free up resources if I'm not running DNS. LPD is another process. This is the printer daemon. So if I'm not printing on that server, then I don't need to run it. And inetd and the portmat services, if I'm not running MySQL or Apache or SSH or something that's going to be running along with some other independent application, then I really don't need to run the inetd, and I don't need to run portmat if I'm not running an FS server. Okay, so let's summarize Chapter 6. Installing most Linux distros virtually is pretty much an identical process than installing them physically. Also remember that Linux is a very efficient operating system. So that means that I can install it either physically or virtually using less resources, hardware resources, than I can most operating system environments. VMware tools, even though they are installed to enhance the user experience, improve performance, provide interoperability between the host and the virtual machine, they do require some installation considerations in a Linux environment. And certain Linux processes and components can and should be eliminated from virtual machine deployment, as they waste a lot of resources. They can also pose some security risks and may not even be applicable to the virtual deployment. Okay, so move on. We'll look at some Linux how-to segments in here, and we got lots and lots more to talk about when it comes to virtualization. We will eventually be moving into Hyper-V and VirtualBox, so stay tuned.